Hello, everybody. We are here today to talk about the serverless framework, meeting Knative with OpenShift Serverless. First up, Roland, would you like to get us started?
Yeah, sure. Let me start. So actually, welcome everybody. So today we want to talk about the serverless framework together with Knative. So I'm really excited that we made this kind of collaboration where we are able to use the serverless framework as a front end for deploying on Knative as well. And today we want to show you actually a little bit about what Knative is, what OpenShift Serverless is, what the serverless framework is, and also what kind of with demo what we have achieved so far. And I think it's really quite nice. So I'm really excited about that. So I suggest that I'm starting now with a little brief introduction about what we think about what serverless is and what Knative and OpenShift Serverless is before we then jump into the serverless framework. Now, so let me share my screen. So. Okay. Yeah, first of all, let's introduce ourselves maybe. So yeah, I forgot that part. So my name is Roland Huß. I'm a principal software engineer working on Red Hat. I'm working on Knative, and I'm also part of the OpenShift Serverless team for the product, which is based on Knative. I have the role of an architect there. And yeah, that's me. And yeah, Austen.
Hello, everyone. My name is Austen Collins. I'm the CEO and founder of a company called Serverless. Most people refer to us as serverless.com because that's our domain. Also, I'm the creator of the Serverless Framework, a pretty popular open source application framework for building serverless applications. Currently, we're just about to hit 38,000 GitHub stars, and we've been working on that project for about 5-6 years now. And it's got a lot of adoption and makes serverless application development really easy. And I'm excited to show off how the serverless framework works with Knative via OpenShift today.
Yeah, cool. So, but before we really jump into the serverless framework and in OpenShift Serverless, the first question is, of course, yeah, what is serverless at all? But everybody has a kind of idea what serverless means to him or her. But actually, I think if you ask 10 different people, you get 8 different opinions on that, maybe. And even this poor guy here is really not poor guy, but actually, in some sense, he is really has some, yeah, is correct in some sense. So is it really more than a CGI bin or not? So we think it is actually, but often it's not so hard to explain. So let me try to explain the difference between serverless and fast as I think it could be defined for. So this is my take on this. Doesn't have to be the perfect definition, but actually I think this is a kind of a valid point. So first of all, I think serverless itself is kind of a deployment model, which means actually that you can abstract away the way how your applications are running on a certain infrastructure, which means that you do not have any server management to do on your own. So there's no active server management required. So everything is done for you behind the scenes. And of course, the benefit for this is that you can, if you do it right, then you can execute your application and scale it and also build it according exactly to the demand of your applications itself. So there's no kind of server running in the background all the time, wasting resources and money without doing anything. So yeah, so I think this is one of the most attractive features what people connect to the serverless model. But serverless itself does not dictate the way how you really deploy your application. So it kind of defines a deployment package format. So to put your application to this platform, but otherwise a serverless platform is kind of application agnostic, which means it doesn't really care about how your application looks like. This is a bit in contrast to a FaaS, a functional service, which I would consider to be a programming model that also actually mandates developing the way how you develop your application. So it often are used for fine-grained functions, and these functions typically match a certain signature, which is given by your function framework. So a typical example of, or probably the most prominent example of this is Lambda, Amazon Lambda, which allows you really to easily deploy your very fine-grained functions to the platform. But this is not so much suited for other architectural models like microservices. So even if you want to run a monolith in a serverless way, then function as a service is probably not the way to go. And often it's also used as a kind of a glue code, which connects services. And of course, for AWS, this is really awesome because you have so many services that you can connect together and create business value out of this. Yeah, and I have to say, of course, typically a functions as a service is also based on a serverless deployment platform. So this is, as I mentioned, this is my take. It doesn't be to be the full truth. It's something kind of a certain angle how you approach that. Okay, let's now jump to Knative. So Knative actually is a serverless platform, as I just have described. So it allows you to deploy your applications and operate them in a serverless way. And the deployment format I have just talked about, this is indeed the container image. So an OCI container image is exactly the format that you deploy on Knative. And Knative itself consists of out of two parts. So one is Knative serving, and serving really cares about all the way how you can serve your data to the outside. It has certain characteristics, like it can scale dynamically based on the traffic that it receives, the application receives. It can scale to 0. It can scale up automatically, and there's also some characteristics which I'll show you in a second. And the other big part is eventing, which is really kind of a common infrastructure for consuming and producing events that are more or less than the input, the data for your applications. So today we're not so much talking about eventing itself. Yeah, so serving, so Knative, you can get a Knative installation on many ways. So if you look on the Knative website, there are 7, I think at least at the moment, there are 7 offerings that you can use directly. Of course, you can install Knative yourself on any Kubernetes cluster. It's super easy. And one of these offerings is OpenShift Serverless, Red Hat OpenShift Serverless, I have to say. And this is the part where we are working on, and this is tightly integrated into Red Hat OpenShift itself. And the key features of these OpenShift Serverless, and of course of Knative. So actually I have to say that OpenShift Serverless is more or less a one-to-one relation to Knative. So every feature of Knative you find also in OpenShift, and there is feature-wise, I think they are the same. And as I mentioned, it's all about containers. You can easily deploy containers. It's about immutability, so which means that if you change the configuration for application, this gets stored in a revision history, and you can easily, for example, roll back to a previous state if you like to. And also with this kind of immutability, you're able to create some kind of A/B scenarios for A/B testing, and automatically, for example, route traffic to different versions of your application. Automatic scaling, I already mentioned, so there's no need to configure any fixed replicas, but it's really done based on the load your application receives, which is really super awesome. If there's no load at all, then you don't have to pay anything because your application won't consume any resources. Because it's OpenShift, it's also available on many different platforms. So it's really ready for the hybrid cloud. You can use, because it's a container base, you can use any programming language. And as mentioned, it's also defines kind of an eventing mesh, an eventing driven architecture, which where you connect together your applications. So this is all Knative and OpenShift. They share all the same features. There are some minor things which OpenShift Serverless has in addition to Knative. So of course, as I mentioned, it's tightly integrated into OpenShift itself. So if you have an OCP cluster for OpenShift 4 cluster, then you can directly install OpenShift Serverless from the catalog. Operator catalog, so it's backed by an operator which is running in the background. You can install it more or less with one click. So, okay, this is a little bit exaggerated, so it's a little bit more than one click, but actually it's nearly one click. And we are really talking to this one click installation experience. And there you go. So you don't have to do much if you have OpenShift. You can also download, for example, the CLI, which also happens to exist for Knative directly from this console. And the other big point what OpenShift Serverless brings onto the table is it really gives you a rich developer experience. What you see here is an example of how you can manage your Knative objects and resources directly on the web UI and connect them together. What you see here in this example is kind of an eventing setup where 2 sources are used to pump in events into a single service. One with a broker, the other one via a channel. So this was really about what OpenShift Serverless and Knative is in kind of a nutshell. there are, of course, there are many more things to tell about, but today, as I mentioned, we want to see the combination with the serverless framework, and this is also a really very exciting piece of software. So I hand over to you, Austen.
Okay, well, if you go ahead and jump to the next slide here. That was a great overview of Knative. Fantastic technology for those who want to run their own serverless compute platform. It's been around for, I think, a few years now, and it's really come a long way. Now, where does serverless framework come in? Well, we are focused on the application experience, really helping developers build applications on serverless platforms, on functions as a service. Because if you look at a typical serverless architecture, it's a bit different from a typical architecture, in that you have a lot of different units of deployment. You have all these different functions that developers are provisioning, and each one of those functions has its own infrastructure dependencies, databases, storage buckets, API gateways, all types of things. And when you really start building these application architectures, these serverless architectures, the thing that I think teams struggle with most, that developers struggle with most, is a great experience for basically deploying these functions, writing them, developing, deploying them, and integrating them with all the other infrastructure dependencies. And that is the problem that Serverless Framework solves. So our goal here is zero friction serverless application development. We help you deploy your functions as a service, and as well as all the other infrastructure dependencies that those functions have. And we try and keep it really simple for developers. We have a lot of high-level abstractions that are easier for developers to approach rather than the low-level infrastructure. And we've come a long way. We've been doing this for quite a while. We've got pretty widespread adoption in the Global 2000, but from everyone, from startups to Global 2000, we're pretty widespread. We're open source. Serverless Framework is something that anyone could use for free today on GitHub. And the adoption of Serverless Framework in the open source world has just been increasing almost twofold every single year since we started. Roland, will you go to the next slide, please? So what is the first killer feature? When serverless and the architecture came out and developers were confronted with this problem of all these units of deployment, all these functions, and trying to bring order to defining those, developing those, and their infrastructure dependencies, we came out with high-level abstractions and a great CLI that really made this easy, as well as a simple YAML file that helped you define your functions and events in a very easy way. And this experience made all that infrastructure that was fairly complex accessible and easy for developers to work with, and gave them an experience that they were more familiar with that helped them just focus on logic and events. So the experience is the #1 killer feature of the serverless framework. And if you think about it, what we see is that when you reduce the overhead of your infrastructure and you're working with serverless infrastructure on something like Knative, what happens is in your organization, you liberate a lot of productivity and you liberate a lot of creativity. And what follows is your developers start building a ton of applications. So it's not uncommon for us to go see an organization, a large organization that's doing serverless development, and they may have 2,000 to 5,000 functions. And that's pretty incredible, and it's just evidence to show off the levels of productivity that you can reach with this new infrastructure that has radically low overhead. And so we started with this CLI that offered developers a great experience to help them get up and running and develop and debug their applications. And then we've slowly been expanding from there. And if Roland, you can go to the next slide, please. We kind of realized that these organizations that were practicing serverless architectures, they really needed a full total serverless solution. They were hitting levels of productivity that were just unprecedented with any other technology stack. So when you have 5,000 functions, and some of these organizations, they only had about 30 developers doing about 5,000 functions. And you can imagine what the world is going to look like in a couple of years as serverless goes increasingly mainstream, the tooling gets better, and a lot more developers are being onboarded in organizations to do serverless architectures, we're going to end up with a lot of logic out there in the cloud. So we've been following that trend, and we've been trying to expand to offer this total serverless solution. So we're not just a great CLI that gives developers a clean, fast, easy experience for getting up and running and building their serverless applications, but in addition to that, we're trying to build in every other aspect of the application lifecycle all into the framework, so that when you deploy with the serverless framework, we're going to help you set up monitoring instantly. We try and offer a zero configuration experience, so you don't have to instrument anything. It just happens out of the box if you use serverless framework. We also set up alerts for you out of the box, give you an explorer so you can see every single API request, every single function invocation, and kind of do a drill down to troubleshoot and figure out what went wrong and where. We have policy enforcement that you can do in our platform now, and a ton of integrations. And this is what we see a lot of organizations need as they scale serverless development, and especially large organizations who are trying to solve the problem of standardizing serverless development across their developer teams. So that's it. Roland, you want to head to the next slide? Most importantly, why are we doing this? Why are we doing this collaboration? So Knative is a fantastic technology for running your own serverless compute platform on Kubernetes. And a lot of organizations want to do this. They really want the flexibility, the portability, so that they're not locked into any specific vendor, so that they can write code, that they can move around easily, so they can practice hybrid environments, have some stuff running on AWS, maybe multi-cloud on Azure, as well as some other self-hosted way of doing it. And so by partnering with OpenShift and their serverless offering, the serverless framework is just trying to bring an even better developer experience to that. So this is kind of the first time the serverless framework, we've typically focused on public cloud infrastructure providers, but this is the first time we've had a great integration with a hybrid compute platform. So now we're trying to bring that great serverless developer experience to enable developers to build these hybrid serverless applications by way of Knative and OpenShift. So I think that's the first big kind of value prop of this partnership that we've started here. And then second, something else that serverless framework is really good at is, again, when you look at a typical serverless architecture, it's not just about the functions. That's about 50% of the value. The other half of the value is all the other infrastructure services that your code and your functions interact with to do more use cases, databases, cloud storage buckets, all that. And we see a lot of developers using other serverless services out there that have typical serverless qualities like auto scaling, never pay for idle, pricing. And they're trying to compose all this stuff together to deliver these applications that have radically low overhead. And so serverless framework is great for helping, in this initiative in particular, helping developers have a great developer experience to deploy code onto Knative anywhere and have that portability and that logic. But serverless framework is also going to help you provision other resources on the cloud providers, like an AWS DynamoDB table or an AWS S3 bucket. So it gives you kind of the whole optionality, whole choice, and the easy experience around that to spin up those serverless applications. So those are the big two key value props that we see with this partnership.
Okay, cool. Yeah, so I think it's now time to show off what we have at the moment. So actually we have prepared some demo which shows actually the results of this cooperation and how you can really integrate deploying Knative on OpenShift Serverless with the serverless framework, which we are very excited about. So maybe Austen, you jump onto the demo and what we have prepared so that you start with this.
Sure thing. I might just take over the screen share for for a few minutes here, Roland.
So stop it here.
And I should be sharing. Can you see this?
Yeah.
Great. So to make this real and show off this technology here, we've created a simple demo. We're going to try and build it live. So full disclaimer, it's 8 a.m. here. I'm still trying to have my first cup of coffee, but Roland and I are feeling very ambitious today. And so we're going to work and deploy this serverless application together. as kind of a small team here. And so this is what we're going to try and deliver today. It's a full stack application that's running on a mix of technologies. So the backend is actually running on Knative via OpenShift, and the backend is going to be using Express.js, the application framework, for delivering a simple API. And so Roland's going to be in charge of that piece. And at the same time, I'm going to provision a front end using AWS resources. So I'm going to provision a simple website to front this full stack application. It's going to be running on AWS S3 as well as AWS CloudFront. Typically you could easily serve a website, from Knative as well. It's very flexible, but we wanted to show composition, kind of blending these services together and how easy that is. And furthermore, I might deploy a few other resources as well to kind of show how you could build out that full stack application, not just deploying the backend code, not just deploying the static website, but also let's see if we can get a database up and running as well. So very ambitious. And again, we're going to be trying to work on this demo together in real time. So not only is it a live demo, but there's going to be two people working on it at the same time. But that's important because, if you're an organization, if you're a developer team, how you collaborate on this technology, on this architecture is one of the key problems you have to solve. Because when you look at, what a serverless architecture is, it's using a lot of resources that just exist on the cloud. And how your team works on all those cloud resources without stepping on each other's toes, without colliding with each other's, is super important. So we're going to kind of give you a taste of how that can work here, all via the serverless framework. So the serverless framework is going to be the application tool, deployment tool, development tool that we're going to use to provision all of this. And we're going to start off with the CLI. Let me just go ahead and give you a quick look into this application. The template, the full stack application that we are showing off today is actually up on GitHub. We just put it up. You can see it here at this address. And this is what the project structure looks like. So this is a serverless framework template. You could easily install it, and we'll get into that in just a bit. But it has 4 different components within this full stack application. There's the backend, there's the website, there's also an AWS IAM permissions role, as well as a database. And let's just take a quick peek into this. Here's the backend, and each one of these, what we call serverless framework services, aka just a project or a part of an application, is declared by a serverless.yaml. So in here, you'll see where we have a common app that we're going to deploy this service into. We're going to use a serverless framework technology called components, and we're going to use the Knative component. And all the component is a library of code that knows how to deploy a specific use case. So this component right here, if you bring it in and declare it in your serverless.yaml, it's the Knative component, and it will help you deploy any source code up onto Knative. And here we're just going to specify the location of the source code, and that's it. This is all you need to get up and running to deploy. And Roland's going to show this off, an Express app up onto Knative. So that's the back end here. Furthermore, we've got the front end, which is very similar, a serverless.yaml file. You can see it's defined under the same application, full stack Knative, and it's going to use the website component. And the serverless framework website component knows how to deploy a static website hosted on AWS S3 as well as AWS CloudFront for a CDN really easily. And all you have to do is just specify the source code of your website. You could kind of run a hook to build your website on deployment. So if you have your typical React application or Vue application, you can build and bundle and minify that code before you upload it. And this will do all of that. Again, these YAML files look really simple, but they actually extend to have a lot of configuration to provide developers with all the customization that they need. But we like to show off how simple it is to get up and running with this technology. So already those two pieces, we've got the backend running on Knative, and we have the front end running on AWS S3 as well as CloudFront. And furthermore, we're going to provision a few other resources. We're going to provision AWS IAM role so that the Knative backend has access to reach into AWS and has permission to interact with the DynamoDB database table. And we're also going to provision that DynamoDB database table, which is all defined, all this is defined, of course, with the serverless.yamls using components that, again, specific deployment recipes for specific outcomes. So with that said, I'm going to go ahead and hand it off to Roland, and we're going to try and kick this off with just deploying the backend first and showing that off. And then he'll hand it back off to me, and I'm going to try and deploy the front end, and then we'll build this out slowly from there. Does that sound good, Roland?
Yeah, perfect. So let me
Okay.
take over the screen share here. So here we go. You should see a terminal. Okay, so what we are here. So actually what I have here is just checked out the repository as Austen has shown you. So actually we are here in the backend directory. And as mentioned, we have already seen that there's this serverless descriptor, which really depicts the Knative component. And this is a thing that we have developed together in collaboration. And this Knative component actually is also valid for OpenShift Serverless. So it's transparently detects in the background whether it's running against OpenShift Serverless or against Knative, and then performs possibly some different step, because the way we not only have to deploy the service on Knative or OpenShift Serverless, but we also have to build the application in a container image. As I mentioned, the deployment format for Kubernetes or for Knative is a container image. And so this has to be created, and this works differently for the Kubernetes case and for the OpenShift Serverless case. But before I go into more details, let's start to deploy that. So actually, this is very super simple. So you have this descriptor, you have a kind of a configuration file, which is one called .env. And this is about declaring your credentials for connecting to the cluster. These are all described in the description for the component. So you need the URL to the cluster, of course, and you need a token to authenticate yourself. And yeah, that's it mostly. So let's start that. And what's happening here now in the OpenShift case is that the component will detect that it's running against the OpenShift cluster, and then it will leverage the S2I build component of OpenShift to create the container image, which means, and more to be more specific, it's not only S2I with source code, it's S2I using a Docker file and a binary input. What this means, I'll show you in a second. So it's creating the container image within the cluster itself. It's stored in the Red Hat OpenShift internal cluster registry, or image registry, sorry, and then creates a Knative service which references this image afterwards. And this takes around 45 seconds, 48 seconds, depends on how whether images has been loaded or not. So let's see and hope that it's finished here after 49 seconds. And then it returns back to you the name of the Knative service, of the service URL, which you can just, for example, use curl to connect against. And let's do that here. And you will see that you get back some kind of a nice JSON greeting. We can have a quick look into the source code as well, of course. So if you look here into so this is the whole application I have. It's, as I mentioned, it's an Express application, and it takes over a query parameter called name, if it's given. If not, it uses a default, which is Knative user, and then just creates a super simple answer. And of course, here you can do much more sophisticated stuff as well, like connecting to an internal database or other services, and just returns back the answer that you just have seen. So this is, and if you change that and run serverless deploy again, then you, of course, you get the updated, a new revision for that. And to prove that, you can look into the service. So what I'm using here is KN, which is a client tool for Knative, which allows you to list all the Knative services. And here we see that it's already has been created. And we also can see, if you look into the revisions, and revisions, as mentioned in the introduction, is a set of different versions. So for each deployment, you get a new revision. And if we look here, we see that we have just created 92 seconds ago a new revision, and this revision gets all the traffic. So, and it works, as I mentioned, with S2I. So we have here a Docker file. The Docker file is specific to the application. It's quite simple here. It uses a node-based image and then just creates npm there. So this is a little bit different to the way as when you deploy to Lambda, for example, because you do not need to create a container image for that. But in our case, we are creating the container image, but it's not, there's no Docker running here locally. which does this, but everything happens in the cluster. And in the Kubernetes case, we are using Canico for doing the container build internally, and we make the upload of the source code here via persistent volume. So there are more steps involved. So STI is a little bit simpler than in the plain Kubernetes case, but it works the same way. And from the outside, from a user's point of view, it looks all the same. So it doesn't really matter whether you're running against an OpenShift cluster, whether you're running against Knative. So yeah, I think that's it for the backend part. What I have to think. So, but I hope you have seen that it's really super simple. So you just specify the component. You have also, if you like, there are several templates which helps you to start up to create a initial application for you. So for all the scaffolding, you can use serverless templates. And yeah, it was very easy to create this application. So this was the backend. Now back to Austen.
Cool. And I just want to speak to one benefit of what Roland just showed off. If you're coming from the domain of AWS Lambda, one thing that Knative does that's really important is it allows you to deploy anything in a serverless fashion. And if you're coming from AWS Lambda and traditional functions as a service, you have a function signature, and you have to think about how to handle all your logic within that function signature. And that's a very powerful, very simple model for building out a bunch of applications in logic. However, I cannot tell you, after doing 5-6 years of serverless development, how many times I've kind of helped out a large enterprise that have a lot of developers working on these serverless apps, and they've all kind of built these custom web frameworks or routers within their Lambda functions and those function signatures. And so while they went out to build these serverless applications, they kind of ended up trying to build their own web frameworks within those function signatures. However, with something like Knative and what Roland just showed off, you could just deploy a traditional framework that's already well adopted, that is Express.js, and really standardized across a lot of organizations. And you don't have to kind of figure out how to do everything in function signatures. That's one of the great benefits of Knative. You could kind of deploy anything in a serverless fashion. So let me pick up where Roland left off. I'm going to share my screen again. So he showed the backend up and running, which is fantastic. And I'm going to focus on the other parts of this application. Real quick, one thing that Roland did when he deployed was he specified an org flag. And that's one of the important kind of collaboration features here. Every single serverless framework user can create a serverless framework org where they could bring collaborators in and start working on serverless applications together with simple role-based access control in place. And it's really helpful because Serverless Framework also helps you manage credentials too. It's just something we're working on, and we're going to announce our Red Hat provider soon here. But you could put all your credentials in the Serverless Framework dashboard so that you don't have to worry about credential management across a large developer team. You can easily delegate credentials to specific apps and specific things. And that's just one of a few challenges when you have a team working on these cloud applications and using kind of a lot of different services together. So, Roland deployed over to the backend up to Knative. That's up and running. So I'm here. I should be sharing my my text editor here. Let me know if that's not the case. And I'm going to go into the website. So I'm going to deploy this front end next. And here's what the YAML configuration looks like. Again, just using this serverless framework concept called components, the website component that knows how to deploy any type of HTML, JavaScript-based technology up onto AWS S3 and AWS CloudFront. So what I'm doing here is I have a basic, very common React application. And I'm going to upload this React application via the website component onto AWS S3 and CloudFront. I'm going to do a quick build of the React application to minify it, bundle it, and then upload that to AWS. So I'll CD into the website here, and I'm going to do a serverless deploy and also make sure that I'm going to deploy into the Red Hat org. I have quite a few orgs. So let me go ahead and do that right now. So again, behind the scenes serverless framework is deploying AWS S3, deploying AWS CloudFront, and it's going to configure those pieces of infrastructure to give you a website right here. And you can see outputs, every serverless framework component that you deploy, it accepts inputs and returns outputs. Dead simple programming model. And you can see those outputs put right here in the CLI. So this is the website up and running. I'm going to copy this code here and plug it in here. And here we go. Here is our static website up and running on the cloud in 9 seconds, which is pretty darn good. And so one thing we focus a lot on is really fast deployments. If you're a developer who's working on cloud infrastructure, there's a lot you could do to emulate a lot of these cloud services locally. But one thing we're focused on a lot right now is just making deployments to the cloud as fast as possible. If you're using a lot of cloud services, and we think that people are using an increasing amount of cloud services, we think a lot of development should actually be done on the cloud as well, wherever possible. And one way we're going to try and make that happen with the serverless framework is reduce deployment speed to almost 3 seconds is our rallying cry internally. So we got up pretty quickly here, about 9 seconds. And so this is up and running. I just want to make sure that when I look in my React code that I have Roland's backend API endpoint here, and this should be it. He gave it to me earlier, and I just want to run it in here in the browser, see if I can interact with it. And there it is. There's the JSON response from his Express backend. So that's in here. I'm just going to deploy it one last time. Make sure that updated code is there. And you'll see on the front end of the website here, just a simple landing page, nothing super special here, and then a form. So what this very, very simple landing page is going to try and do is it's just going to, whatever I type in here, let me refresh to make sure I'm using the latest version. I'm going to put in my name. Whatever I type in here, it's going to simply send that up to the Express backend, and the Express backend is going to return that JSON response and put in the name that I specified in the form. So that's it. That's kind of basic interactivity. Roland and I, we talked a lot, but honestly, to deploy this stuff, to get the backend up and running on Knative in a serverless fashion, and get this front end up and running, we could have, the total time it took us was probably, a couple minutes to do all this stuff, which is incredibly powerful. We provisioned a lot of infrastructure behind the scenes. And the great thing, and the thing that the serverless framework tries to do really well, is that as a developer, you don't have to think about all that infrastructure, right? The team who's kind of managing Knative, via OpenShift, that separate team can work on that and make sure that they're providing the best serverless experience for the application developers in the organization. And the application developers don't have to think about that stuff, which is kind of key to winning over hearts and minds of developers at the end of the day. Because if you give them a lot of infrastructure configuration and syntax, they get a little bit wary of that. So this is best practices built in to deploy these serverless outcomes using this components technology, and keep it very, very simple for the developers. And we were able to get the back end up and running quickly, as well as the front end. So real quick, you can kind of see some of these pieces here in the serverless framework org, the dashboard. Here is the back end that Roland just deployed. You can also see the inputs that Roland specified here, as well as the outputs. You can actually see the URL right in here as well, easily copy it. And in addition to that, you could also see the website that I provisioned. You see all the information, what component it was using, when it was last deployed, the URL of the website. You can see the inputs and the outputs again right here. And some of these components are advanced enough. We don't yet have this for Knative, but some of these are advanced enough where you could actually see metrics out of the box. So now I've got metrics for the website already configured. Didn't have to do any of that myself. I could see requests coming in right here in real time. So pretty powerful stuff. And up next, I do want to show off just some additional basic composition, because while we've gotten pretty far in a very short amount of time, we got the back end running, we have the front end running. There's a lot more if you want to build out a real world application. And so the question next is, how do you handle persistence? Maybe you want to do basic users CRUD, be able to register users on the full stack application. And so I'll quickly provision just a few things to give you a sense of how this would work. So up next here, we have a AWS IAM role right here. And this specifies, basically, this gives you credentials so that only permit access to a DynamoDB table. And actually, I'm going to go ahead and provision the DynamoDB table first, real quick. So I'm going to run SLS deploy or Red Hat. And because this is using the DynamoDB, AWS DynamoDB component, Serverless Framework knows how to provision this and provision it pretty darn quickly. Only about 2 seconds it took to spin this up. Here I've kind of modeled out my DynamoDB table, with just kind of like a basic loose access pattern. And so this is all the DynamoDB configuration, also created a secondary index. So that's deployed pretty quickly. Here are the outputs from the DynamoDB table. And then here is the AWS IAM role that that's going to give permission to Knative, to the backend, to reach into that DynamoDB table. So I'll go ahead and provision this really quickly. Or Red Hat. So I'm going to provision this. And here's where it gets pretty cool, because not only have we kind of provisioned all this infrastructure using the same easy development experience, Serverless Framework really tries to help out a lot with composition, specifically with components. And you can see the database, the DynamoDB table, exported some outputs, specifically the DynamoDB table name and the DynamoDB table ARN, which is like a unique identifier of the resource on AWS. And every single output can actually be specified as an input. So if you look at the permissions that I'm trying to define right here, down here, you could see that I'm doing a reference using something called Serverless Framework variables. And I'm referencing an output of the database service over here, and I'm referencing the ARN of that DynamoDB table, and I'm referencing also the index that I set up on that DynamoDB table. And so all you're looking at here is this is a permission that gives specific access only to this DynamoDB table, gives these specific actions, access these actions on this table. And by simply using references, it's very easy to compose things together and share configuration. And now what would the next step be? Well, the next step would be simply to go into the back end here. And this Knative component actually supports environment variables. And you just specify, I think the syntax, and Roland, correct me if I'm wrong, it's either env or the environment property.
That should be correct, env, I think.
Yeah, so you could specify environment variables in your Express application in that kind of Node.js environment right here. And I could simply go ahead and reference, I'll copy this syntax, this will be easier. I could specify the permissions ARN. And so what this would look like to actually interact with Express, interact with the DynamoDB table in my Express backend is I simply get the ARN and the permission information, and I use the AWS SDK in the Express app in the backend, and I use the credentials that I get out of this that I'm going to pass in via the environment variable to go and reach out to AWS DynamoDB. And that's really it. Simple composition using these output references. And these could get pretty advanced. So not only can you just specify the name of the other service and one of the outputs in particular, but Serverless Framework also helps you provision things across different stages. So you could quickly do a serverless deploy and stage and just do maybe a test or a feature stage. So you could provision the resource in a whole new instance of the resource in a different stage. And then you can start getting into cross-stage references, which opens up the door for a lot of collaboration functionality. Basically, have a shared development environment with a lot of resources, and then let your developers spin up feature stages of specific parts of the application and reference the other parts of the application in the dev environment. So this stuff gets pretty sophisticated, helps you do a lot of unique infrastructure referencing to help solve team collaboration problems of a lot of infrastructure resources. So this is it in a nutshell, how you get a full stack app up and running, the back end as well as the front end, and start bringing in some other pieces like your database, for example, and a lot more, anything else on AWS Cloud. And you can go ahead and look, again, all these things are now here in the dashboard. We've got the database, we have the permission, you can see the outputs that were specified for each one of these. And even in here, you can kind of see the input references as they were populated. So here I was referencing the ARN from the permission, and that is now fully populated in the input here. So pretty powerful stuff. Serverless Framework goes much further. You could specify parameters here, which is great for infrastructure resources that you provisioned elsewhere with other technologies like Terraform or something. These you could specify as environment variables into your application code as well. And it makes it very easy. Serverless Framework makes it really easy to collaborate on all of this. And one way that this is going to be pretty even more useful in the future is that OpenShift, Red Hat are coming out with a dedicated OpenShift service on AWS, and they also have it for Azure. And I think they're going to expand that pattern a lot more. And the benefit of this is that you're going to be able to run OpenShift on AWS as a service that you don't have to manage, and you could run you could leverage Knative and the serverless experience that Roland just showed off, and especially the serverless framework experience to actually reach out and interact with other AWS resources. Very, very easy. So this is a great solution for if you want the power of Knative, if you want the portability, the flexibility that offers, and a great developer experience for your developers to kind of interact with that platform and spin up other resources that they're going to need to build out those full real-world serverless applications. So I think that's it, unless, Roland, you have anything else you want to add on top of that?
It was perfect. So I think, yeah.
Well, cool. So in closing, we have a few links for everybody checking this out. So first off, there's a link to the template. We're going to continue to iterate on this in the near future here, but this basic foundation is up and running. It is available on GitHub. Again, if you want to check out the Knative serverless framework component and how that works, you could go directly to that and see what it can accomplish. A link to Knative is there as well, of course, as well as the OpenShift serverless product that Red Hat offers and the upcoming OpenShift service on AWS. If you want to learn more about that, there's the FAQ and serverless framework. For all things serverless framework, just go to serverless.com to learn more about the serverless framework. And that's it. I think this is, again, a pretty powerful experience. This gives you choice, flexibility, like at least serverless framework users have never really had before. And the power of Knative, the power to run anything kind of in a serverless fashion is really going to push the boundaries of kind of what we think of as serverless applications and what they can do. And hopefully this gives your developer teams a great experience for rapidly developing applications and having a lot of kind of choice and flexibility in how they compose those applications out of different infrastructure resources. So with that, thank you, everyone. Roland, I don't know if you have any other closing remarks.
No, also thank you, everyone. And I can confirm this was really a great experience for me also to work together. And it was really surprising. I was really surprised how quick and how easy everything fits together. So it was really very pleasing.
Yeah, thank you both, Roland and Austen. This was really, really amazing. I mean, the demo, the walkthrough, very clear. The feedback in the comments, I was monitoring that. That was very positive as well. So I'm sure people definitely take it for a spin. And with the link here for the GitHub project, they can also just reproduce this experience locally, right? They can just build the demos themselves as well. That's awesome.
Although it'd be great if one of you had a link to the slides that we could drop in the chat. That way they can not have to screenshot what we're looking at right now.
Yeah, sure thing. I guess I'll just make this public, and then I'll drop it in that. I'll drop it in the chat.
Cool, thanks. And we didn't see any other questions. Marquito, did you have any other questions you wanted to bring up?
I think the only question I had from someone on the chat was about the consumption of AWS services from the Knative service. I think Austen was adding the environment variable there, and the question from the audience was just about, like, can they do that with any AWS service, so S3 or Dynamo or any other database?
I'm sorry, William, the question was referencing outputs from any AWS service?
Yeah, when you were editing, I think the environment variable value from the Knative service pointing to, I think, a database in AWS, the question was, can they do that with any other AWS service? And does that work when OpenShift is running on-prem, of course, with access to those services?
Yeah, so Roland might have to speak to if what some of the dynamics you might have to run into if you're running this on-prem. But as far as kind of the experience that Serverless Framework can provide, our hypothesis is that the cloud, a lot of public cloud services, that serverless is just the natural evolution of the cloud, and specifically how we think that's going to shake out is that almost every service that you see on the cloud today, whether you log into Azure, Google Cloud, Tencent Cloud, or AWS, every single service in there is going to increasingly have serverless qualities, auto scaling, never pay for idle pricing. And there's going to be a lot more new services that these cloud providers come out that, again, have the same qualities and are kind of higher levels of abstraction. So we think serverless, just the natural evolution of the cloud, that's what we think it's going to look like. And this is great. I mean, these are like the greatest building blocks of all time. If you're a developer, if you're an organization that really values innovation and moving quickly with low overhead, this is just a fantastic time in cloud and in software development and innovation in general. So where do we fit in Serverless Framework? How do we want to try and help organizations prepare for this? Well, we've done a great job of offering support for all the services on AWS as well as some of the other public cloud providers. We still have a long way to go, but we have support for a ton of the AWS services and services on Azure. So just like I spun up DynamoDB, AWS IAM, you could do the same with AWS S3 and all the resources there. And yeah, that will work. All you have to do is just pass that information directly into Knative. And furthermore, one thing that is different about Serverless Framework is that we're totally vendor agnostic, right? We want to be the level playing field for all these services that have serverless qualities, regardless of the vendor. We're going to give you a same seamless experience for picking all these off the shelf across platforms and composing them together to make these applications. And the beauty of Knative is just like the flexibility it brings to the custom code that you can write to interact with all these services. It's just kind of like the last big critical piece. So TLDR, yes, you could do that for all types of AWS services, and Serverless Framework in the near future here, you'll be able to provision Stripe or Twilio or Salesforce stuff just as easily as anything on AWS or Azure.
That's awesome. That's awesome. Thank you, Austen. Yeah, that's great.
Well, thanks to all of you for being here on OpenShift TV. Serverless is actually one of my favorite kind of advancements in kind of the technology space. I really do think most software is going that way. Just want to say, coming up next, we have Dev Nation talking about Odo 2.0 and using that with Kubernetes. So check that out. That's in about 6 minutes, give or take. And then later today, there's Spanish language OpenShift Commons, and then and that's about whatever. I always try to give time based on now, so about 4 hours from now, or sorry, 5 hours from now. Otherwise, you can always check out the streaming calendar, and as they like to say on the YouTubes, don't forget to hit that subscribe button. And thanks so much, and we'll see you all soon.
All right. Thanks, everyone.
Bye-bye.